Hello. So, I can start? Okay. Hello, everybody. So it's my great pleasure to be here to present Web3 URL, which turns the Ethereum into a we call Unstoppable HTTP server. So a quick intro of myself. My name is Chi. I'm a founder of EthStorage and Quadchain. I've been working in this space for more than 8 years. Before that, I was a software engineer at Facebook, Google, working on their infrastructure system. And so that's why my primary interest in Web3 is in Ethereum scaling in terms of, for example, layer 2 and peer DAS. And so we also receive a couple of grant supports from Ethereum Foundation, also includes a grant from personal grant from Vitalik. So first of all, what is Web3 URL? It's an access protocol which is similar to HTTP, but rather than using centralized, for example, domain names and also server, we're using Ethereum as the corresponding server and use smart contract to host the corresponding server-side code to tell what kind of the web front-end you want to display to the users. So here is an example of the Web3 URL format. It's very similar to HTTP, but we replace the corresponding domain with the smart contract, and also it supports multi-chain so that we can put the chain ID, and also a way to how to call the smart contract so that we can know how the smart contract would like to return the web content by executing the smart contract on chain. And it's defined in the EIP 4804, so which was finalized I think 2 or 3 years ago. So question, why we want to have this protocol? What is the starting point? So when we developed this standard about 2 or 3 years ago, we saw there's a great trend of fully on-chain applications, where not only the protocol is running on top of smart contract, on top of Ethereum, but also a lot of metadata, like front-end images are also on-chain. So one particular example is NFT, where we saw a couple of the NFT projects. Now they are moving all of their metadata, including images, on chain, so that you buy not only just a simple ERC token ID, but also corresponding all the assets that can be found on chain, so that people can always access this content rather than, for example, 4 or 5 years ago, some of the NFT images just disappear because you're using centralized servers to host all these images. However, when we take a closer look of all this NFT data, it uses third-party, for example, Moonbirds, which is famous for using these images pixels on chain. And if we check this token information, then it's still using a centralized server, HTTP, blah, 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 something, to display the corresponding images. Another famous is called cyber brokers. They upload a lot of vectorized images on chain using SVG format. But if we take a closer look on its image data, it's still using IPFS. So to our surprise, those data are already on chain, on top of already upload to the Ethereum. They pay $500,000 or millions of the dollars of Ethereum to upload this data. But there's no way on top of Ethereum to access this data directly. So we still rely on third-party services. And so, hey, we have to use something new to change this. And that's our starting point to develop this Web3 access protocol. So the motivation is that with this Web3 access protocol, with a very HTTP-like link, now you can call a smart contract and tell, hey, what is the corresponding data that you want to display on the website? So that we can put in this in the future, for example, we can put this Web3 URL link, and we can directly grab corresponding data, corresponding images from the blockchain network. And so OpenSea actually also already support Web3 standard besides IPFS or these centralized servers early this year. So that now when you browse OpenSea, actually you will directly find the corresponding images on chain and display to the on the front end. And so to do so, then the corresponding metadata of these images now can be just replaced by a Web3 URL link telling which contract you want to call and what is corresponding info of these images, and then it will return those images for all these NFTs. And all those links are actually live on top of the Ethereum network. And so how to use Web3 URL? Actually, it's very similar to HTTP. It inherits most of the HTTP features, except that we replace the centralized server entities or this thing by a decentralized authority. It can be a smart contract address hosted by the full address, or an ESN name that registers corresponding address of the contract. And second thing is that a way to how to call the contract so that the contract will return corresponding front-end data. And lastly, additional HTTP information that tells what kind of additional format of this data, like for example, MIME, and for example, error code, or a couple of other things that you can define in this Web3 standard. Okay, and to use Web3 URL, here is from user perspective how the Web3 URL will interact. So a user will type the Web3 URL link in the browser that support Web3 URL, and then the browser will pass the corresponding information through JSON RPC of Ethereum and tells what is corresponding address, what is the core data, and how to call the contract, return the content. And we know that HTTP is a composable protocol. So HTTP page can contain a couple of the subpages. So this will further turn this subpage calls into future further Web3 calls for example, images or JSON file. And then so this process repeatedly until all the content has been resolved and then return to the front end of the user. So for the relative address resource resolving, this is basically directly inherited from HTTP so that we can fully power the existing feature of HTTP and while just replace corresponding centralized component with Ethereum. And so how to access this on-chain data with Web3 URL? So right now, we are still working similar pathway as IPFS. Now we have a gateway, which is open source, so you can run also your gateway. And then the gateway will just replace corresponding contract with subdomain and call also the corresponding call in the link. And then now you are able to access the corresponding content, which will call the corresponding Ethereum JSON RPC is a calls for the front end. And we also support basically a Firefox plugin, which will allows you to just type this Web3 URL link, and then will automatically translate to the gateway address, so that the user can also just directly access without knowing how to translate the Web3 URL to HTTP. And we also support a community project, which he built a standalone EVM browser so that it can directly, on the front-end side, to directly pass this Web3 URL to corresponding contract call and display the content. So this is super powerful, which means that we don't rely on any centralized component, just directly at a user side perspective to complete all the display calls and display all these tasks on the client side. So this is kind of our full goal of fully decentralized access. So for applications, this can enable a lot of applications. Imagine all kinds of applications built on top of HTTP, as long as all data is public. For example, Wikipedia, all kinds of the public information now can be built the corresponding fully decentralized counterpart using our standard. So one application is NFT images, which I also gave an example. And I will skip these details. And for example, we also create a personal website using Web3 URL, which using smart contract to simulate a file system so that now we can upload the data just like FTP, but this FTP actually is hosted by the smart contract running on top of Ethereum. So that now I can synchronize my local HTML data website. This is example of Vitalik website, and on top of the smart contract hosted by the Ethereum network. And now we can access this website without worry about any centralized component that may be compromised. So this is another example that we have already actually running on top of Ethereum mainnet. And there are more applications that are exploring. So for example, one interesting idea is to build a decentralized gate so that maybe one day with the scalability roadmap of Ethereum, both in terms of computation and storage, we are able to have the Ethereum to host the full, for example, Go Ethereum GitHub pages, and so then now we can develop Ethereum on top of Ethereum without any centralized components. I think this is really cool. Those are right now the current status, and so we are also have a couple of blockers during the development. One thing is definitely we want more native application support, especially browsers. For example, even though we have plugin, but plugins still rely on some centralized gateway. So we want to work with, for example, popular browsers. Actually, a couple of engineers from Google, they are really interested in this idea. They also have a lot of conversation to see how they are able to support this standard. And we also have support from OpenSea early this year, and now it's already fully supported by OpenSea, so that when you browse on-chain images, that NFTs that with the on-chain images, then OpenSea will also automatically call the smart contract and return the data and display the content for you. And we also found a couple of issues, like there's some malicious reporters saying that, try to block us and say, hey, there are malicious content, or this thing. Actually, this is similar thing happens to IPFS gateway. And so just take more time to convince that, hey, this is a legit thing. All the things are on chain, and we just like transparently relay all this data from Ethereum. So another issue is regarding the storage. So we know like Ethereum is moving towards its new scaling roadmap while increasing the blocks limits of the L1. On the same side, there's also storage issue, because Ethereum, even they are able to process more transactions via a lot of fancy BAL, ZK technologies, but still they need the network to store fully. Every node would store a full replica of the data. So there is also motivation to how we are able to scale this data, especially with the new Ethereum roadmap, which we will basically put a lot of data using the peer DAS, including block space. So we are also working on this direction. We call it EthStorage, which received grants from Ethereum Foundation. And the basic idea is to build storage native system, a layer 2 storage system on top of Ethereum, and use this smart contract to verify the corresponding off-chain storage network. And we also, actually the standard has been also evolving. There are a couple of sub standards that, just like HTTP, we know HTTP have tons of the standard that involve HTTP 1, 1.2, blah, 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 blah. So we are also evolving very quickly. We have a couple of substandards to support different types of HTTPs. So for example, we can also support like standard HTTP request header and standard HTTP response, which is exactly the same. You write a HTTP handler in terms of your like using Node.js or using Golang, but here it happens in smart contract. So we have specified standards so that you can have fully utilize existing HTTP power to do more advanced applications. So today that's all the presentation, and I would like to answer any questions. Thank you very much. Questions?
Thank you for the presentation. So I see the utility for what's read-only content that we can put on chain, and we just fetch it from smart contracts, etc. But do you have a vision or idea about write content when we want to update it? Sorry.
Yeah, that's a really good question. So, HTTP, they have a couple of ways to interact with HTTP. There's a GET request, there's a POST request, and also delete request. So right now, the standard is only defined for GET request. So basically, just return the latest verifiable data from EVM. For example, one example I would like to highlight is, for example, the Bybit frontend attack. The reason is that the Bybit frontend is the server is compromised, so that it returns the malicious content, because there's no way to, the browser does not support a way to check the integrity. So suppose the website is fully put on chain, then now we are able to verify it and also be able to make sure it's always available as the same as the Ethereum protocol itself. So that's the motivation. And for the post one, actually, because if for the Ethereum, like we know, we have to send a contract in order to modify the content. So for that sense, we haven't do a lot of work on that side, just more work, say, there's a couple of other standards to say how to use a link to compose a transaction and sign and modify. But that's not the major direction that we are currently working on.
Hello, thank you for the presentation. I see you will work with a different browser. What about Brave? You will work with Brave also?
So actually, I should put the logo there. Yeah. Actually, we would like to work with them, but I think it would be easier to have some like early adoptions before we convince like those browsers. For example, I can tell one of the major browser here, when we talk with them, say, hey, we have this standard, we want to work with you to support it. Do you know what's their response? I don't want to put their name. They say, oh, give me 1 million, I will do it. I thought, if I have this money, then probably I would put it to more adoption rather than just say, hey, I just buy your engineer to support this feature. So that's the current issue we are facing. Yeah.
Okay, thank you. The extension is, why don't build a browser by default who use the protocol Web3, not HTTP? Some kind of
actually, we have a community browser, this one. So it's a prototype to demonstrate. Now we can use the existing kernel of the browser, and then with some UI interfaces, now we can do the same thing. But definitely you have to configure the RPC, all this information, but it works, yeah. Excellent, cool. Thanks for attending the talk, and if you have any questions, feel free to contact me offline, and I would love to see how I can make the Web3 better.